All right, to start homework number 16, we're starting on problem 12. It says identify the open intervals on which the function is increasing or decreasing. So from here on out, we're going to get this question a lot. And anytime we want to know if something is increasing or decreasing, we take the derivative of that thing and look for where it's positive, where the derivative is positive or negative. So let's find dy dx. Now remember, this equation up here can be rewritten as x plus 4x to the negative 1, if that helps you visualize your power rule. So the derivative of y would be 1 minus 4x to the negative 2. And you want to rewrite that 1 minus 4 over x squared. And because we're looking for critical numbers, we should get this into a common denominator so that we can look for where dy dx is equal to 0 and where it's undefined. So change 1 to x squared over x squared. So it's x squared minus 4 all over x squared. And for our critical numbers, we're looking for dy dx to equal 0. That happens when the numerator is equal to 0, so at plus or minus 2. And we're looking for places where dy dx is undefined, and that happens at 0. Now, I should note back here, I probably should have done this to begin with. There is a discontinuity in the graph of y. Now, actually, it doesn't really matter too much, but x can't equal 0. If I were looking for a relative max or min point, even if the derivative changes signs at 0, it can't be a relative max or min because it's actually a vertical asymptote. So anyway, I found my critical numbers. The next thing to do is to place them on a number line in the correct order. So negative 2, then 0, then 2. When one of the critical numbers is a discontinuity, I like to remind myself of that just by putting a vertical asymptote through it. And what we're plugging into is dy dx. And we're seeing what is the sign of dy dx? Is it coming out positive or negative? So I'm looking at this equation, and I'm just thinking about plugging numbers into it. So something to the left of negative 2 is negative 3. So when you square that, you get 9 minus 4 over 9. So that's positive. It's 5/9, but it's just the fact that it's positive is important. That tells me that on this interval, y is increasing. Something between negative 2 and 0, like negative 1. So 1 minus 4 over 1, that's negative. That tells me y is decreasing. And then if I plug in 1, I get, again, 1 minus 4 over 1. That's because dy dx is an even function, so getting this symmetry here. So y is still decreasing in this section. And then if I plug in 3, I get 9 minus 4 over 9, which is positive. Now remember, for our AP exam, none of this work is going to be looked at or graded. So this does not count for your explanation. So I need to finalize my answer and give reasons for it because this does not justify. Even though it doesn't say justify, you should just get in that habit because we're going to have to for the AP exam. Okay, so this tells me that y is, I'm going to start with increasing on the interval negative infinity to negative 2. And where else was dy dx positive? 2 to infinity. And that's because dy dx is greater than 0. You can use this inequality notation. You need to avoid the word it. Don't say it's increasing or just increasing. You need to say y is increasing on these intervals. And again, it's not because it's positive or the graph is positive. It's not that. It's because dy dx is positive. You have to be specific. Otherwise, what you're saying could be considered incorrect, depending on what we're thinking of. All right, y is decreasing on. So even though I've got negative here and negative here, I can't say negative 2 to 2 because remember, y doesn't exist at 0. So we do have to break this up. Negative 2 to 0 and 0 to 2. And that's because dy dx, or you could have said y prime, is less than 0. Okay, so that's the final answer. And that's all that we were asked to do for that first problem. Okay, we have 4 parts to these problems. So part A is find the critical numbers, if any. So let's begin by doing that. So here's f of x. Are there any discontinuities? No. So I'm just going to make a note, all real numbers. And then f prime of x is what I need to find to start critical numbers. So that becomes negative 4x plus 4. Critical numbers occur when I set f prime equal to 0. And so if I solve that, subtract 4, divide by negative 4, you would get x equals 1. So there's the critical number. Part B says find the open interval or intervals where the function is increasing or decreasing. Now that's what we just did, right? So put 1 on a number line, consider f prime of x. Now you could either graph this or just plug in numbers. I can graph it because I know that a line with a negative slope goes like this. But if your graphing is a little like, if you don't quite trust your graphing, you can also plug in a number to the left of 1 like 0, and that would give me 4. And something to the right of 1 like 2, and that would give me negative 8 plus 4. So negative 4. So I get a positive and a negative, which means f is increasing then decreasing. Okay, so I need to write that down. So f of x is increasing. Again, right? F of x is increasing, not just increasing or it's increasing. That's wrong. F of x is increasing on negative infinity to 1 because f prime of x is greater than 0. F of x is decreasing on 1 to infinity because f prime of x is less than 0. I know that it's annoying to write all of this out, but if you're not doing it in your homework, you're probably going to forget or write something wrong on a quiz or a test. So, do the annoying hard work now so that it's not so difficult when you get to a quiz or a test. Okay. Apply the first derivative test to identify all relative extrema. So I'm going to use this little sketch that I had here, right? So we know that because f changes from increasing to decreasing, there's a relative max at 1. So f of x has a relative max at x equals 1. Explain why. Because f prime of x, it's not just that it changes signs, it's specifically because f prime of x changes from positive to negative. So it's not that f of x, you could probably maybe say that because f of x changes from increasing to decreasing, and again, specify, never use the word it in any of this explanation. But I'm going back to f prime because that's what I've been using for first derivative test. Okay, f prime changes from positive to negative. And then it doesn't say, it just says identify the extrema. So we should probably find what f of 1 is equal to. So if we plug 1 back into here, we get negative 2 plus 4 plus 3. 2 plus 3 is 5. So that is the relative extremum value, relative max at 1, 5. And then part D was just graph and confirm. So I graphed. I'm confirming that yes, I was correct. Okay, we do this again here. So this is a cube root graph. We're finding critical numbers for part A. So find f prime. So that's going to be 1/3. And then it'll be x to the negative 2/3. So I'm going to put x to the 2/3 down here. The plus 1 goes away. There is a critical number when f prime x is undefined, which is at x equals 0. Okay, and when I go to find increasing, decreasing, 0, remember, now it's not a discontinuity here. F of x is defined for all real numbers, but 0 is where f prime is equal to 0. So I'm not going to put in a vertical asymptote here because that's not really what's happening on f, but that's up to you. So we're testing into f prime and we're talking about what happens with f. So if I plug in something negative, like negative 1, you're putting it into 1/3. So remember, x to the 2/3 means the cube root of negative 1 squared. So that's going to be 1/3 times 1. So that's positive. And the same thing is going to happen if I plug in to the right of 0. If I plug in 1, I'm going to get 1/3 times 1. So f of x is increasing and then continues to increase. Now at 0, think about the cube root graph, or here it is right here. At 0, there's this vertical tangent. So if I were just looking at this graph, I would say f of x is increasing for all real numbers. And you can kind of go both ways, I believe, on the AP exam, but I like to stick to my definition. So as long as I justify correctly, I should be okay. So I'm going to say f is increasing on, I'm going to say negative infinity to 0 and 0 to infinity instead of just negative infinity to infinity, because my definition, because my justification is that f prime of x is greater than 0. It's not equal to 0 and it's not undefined, or I mean, it's not equal to 0, it's undefined at 0, so that's hard to like work in there. Now, you could say negative infinity to infinity because f prime is greater than 0, and then f prime of 0 is undefined. Like, you could get into all of that, but I'm just going to leave it like this. So I always, every year, I kind of go back and double check, like, is this acceptable for the AP exam? And as far as I can see, yes. Okay, and then part C is talk about relative extremis. So this one, because f prime does not change signs, there is no relative max or min. And again, you can see it on the graph. So I'm going to say f. I don't want to just say no relative max or min. F has no relative extrema, you can say, instead of max or min. F has no relative extrema. Why? Because f prime of x, you can say doesn't change signs, or you could say remains positive, or whatever. I'm just going to say doesn't change signs, because the reason that there would be a relative extrema is if f prime does change signs. And then there's the graph. 37, we're doing the same thing here. So, okay, so 37. Now, I did a quick mental check. This factors into x minus 1 squared, but I can't divide out x plus 1, unfortunately. I also originally started doing product rule for this, which is okay, but it got kind of ugly in my opinion. So, I don't know. I'm going to do quotient rule. You can do product rule. We should get to the same f prime in the end. So, I'm doing quotient rule. Oh, let's also note, x can't equal negative 1 in this function. That's a vertical asymptote. That just means I won't be able to say negative 1 as a relative max or min if that happens. Okay, so low, d high, derivative of the top is 2x minus 2, minus high, oops, got to write it down correctly, minus high, d low, derivative of x plus 1 is 1, all over low. We've got to clean this up a bit. Let's go ahead and FOIL this together. Now, this is 2 times x minus 1. So x plus 1, x minus 1 is x squared minus 1. Distribute a 2 through that, 2x squared minus 2. You don't have to do it that way, but that's just more efficient to me. And then I'm going to distribute the negative through here. Remember, you don't want to do any distributing in the denominator because that's just a single term and we're just trying to set it equal to 0. But up here, I want to see what I have so I can set it equal to 0. So this leaves me with x squared plus 2x minus 3, which does factor. Okay, so that's f prime. We're supposed to find critical numbers. So f prime of x equals 0 when x, let's factor it, x plus 3, x minus 1 equals 0. So that happens at negative 3 and positive 1. And then f prime of x is undefined when x equals negative 1. Okay, now we still need to plot this on a number line, even though it's a discontinuity, because the graph does break apart at x equals negative 1, and the behavior might be changing, increasing versus decreasing. Okay, so let's get these numbers on a number line. Negative 3 would be on the far left, and then negative 1, and then positive 1. And at -1, I am going to draw a vertical asymptote just to remind myself. Again, this is not, AP does not grade any of this. So I just like to do this to remind myself that at f of x, there's a vertical asymptote. All right, so let's plug into f prime. We're going to plug in -4. And I want to plug into the factored version, like that. So if I plug in -4, I get -1 times -5 over, now if something squared is always going to be positive. So a positive over a positive is positive overall. And then if I plug in -2 between -1 and 3, -2 plus 3 is 1 times -3 over this always positive squared thing. That's a negative over a positive, so negative overall. So far f increases, then decreases. And then plug in between -1 and 1, you can plug in 0. That would give you -3 on top, and again, a positive on the bottom. So that's also negative. So f is still decreasing. And then something bigger than 1, so 2. That would be like 5 times 1 over something positive. So positive here. All right, so for our final conclusion for part B, f of x is increasing on the interval -∞ to -3 and 1 to infinity. And then we say why? Because f prime of x is greater than 0. And then f of x is decreasing on, again, you have to split this up because f of x doesn't exist at -1. So you can't say it's decreasing at -1, but it's decreasing on -3 to -1 and -1 to 1 justify because f prime of x is less than 0. All right, so keep practicing writing this out. It's annoying to write, but it will be so much easier than when we have a quiz or a test. Part C is to identify any relative extrema. So we changed from positive, f prime changed from positive to negative. So there's a relative max at -3 and a relative min at 1. And I have to use the sign change here. So just so I can keep this on my screen here, f of x has a relative max at x equals -3, and then let's justify that because f prime changes specifically from positive to negative. Now, I'm okay with you abbreviating as long as I can read what you're abbreviating on your tests and quizzes. For the AP exam, please write full words out. That would be nice. You should have enough time to work on the test. Okay, and then, let's go ahead and find f of -3. So f of -3, just because it just says find the relative extrema. So f of -3, if I plug into the original f of x, so that's, let's see, 9, -2 times -3 is +6 plus 1 over -3 plus 1. That's 16 over -2. So f of -3 is -8. Okay, and then f of x has a relative min at, I believe it was x equals 1. Yep, at x equals 1. And that's because f prime changes from negative to positive. Don't need a dot there. Okay. And then part D was graph and verify. So here's what the graph looks like. And yeah, there's a relative max over here and a relative min right here. Okay, for the next problem, we are looking on the interval 0 to 2 pi. For each function, part A is find the open intervals on which the function is increasing or decreasing. So f prime, we need critical numbers first, then we put them on a number line, and we test into f prime. So f prime is equal to 1/2 minus sine x, and your critical numbers would be when this is equal to 0. So I'm going to add sine x to the other side. Okay, and we're within 1 unit circle. So what angle makes sine equal to 1/2? That's pi over 6. And then in quadrant 2, sine is also positive, so 5 pi over 6. And then those need to go on a number line. Now, number lines with trig can be a little bit harder. Remember, we're going 0 to 2 pi. Pi over 6 is over here, and 5 pi over 6 is somewhere here. Spacing doesn't really matter. When we did this in AP Pre-Calc. You might not remember, but pi over 6 was here. What we did with these inequalities was we placed the two angles that we were looking at here. And then it was like, okay, between 0 and 2 pi, we need to test a number in here. We need to test a number between these two and something around the circle here. There's all kinds of good options. Now, even though it's the open interval 0 to 2 pi, you can get away with plugging in 0 because if you think about it, we're saying how does 1/2 minus sine of something come out? And we're looking at the sine of any angle between 0 and pi over 6. Remember, sine is like the y coordinate. So any angle that I pick out here, whether it's pi over 12 or 0 or whatever, anything that's in this first quadrant is going to be a positive y value, but it'll be smaller than 1/2, right? So 1/2 minus sine of 0, I'm just going to plug in 0. That gives me 1/2 minus 0. So that equals 1/2. So that's positive. So all I'm saying is you're going to have 1/2 minus something smaller than 1/2. So no matter what angle you pick in there. So that's 1/2. And the reason I didn't pick pi over 12 is because I don't know that exact value. I know it is smaller than 1/2 though. Okay, now pick something between pi over 6 and 5 pi over 6. It's easier to visualize that on the unit circle. I'm going to pick pi over 2. I want to pick non-quadrant angles anytime I can because those are the easiest to use. So pi over 2 is in here. That's 1/2 minus the sine of pi over 2, which is 1. That's negative 1/2, so this section's negative. And then anything between 5 pi over 6 and 2 pi. I think I chose pi on my answer key. 3 pi over 2 would be a good one. But I'm just going to go with pi. 1/2 minus the sine of pi, which is 0, is back to being positive. So that tells me that f of x is increasing on 0 to pi over 6 and 5 pi over 6 to 2 pi because f prime of x is greater than 0. And f of x is decreasing on pi over 6 to 5 pi over 6 because f prime of x is less than 0. Even though these problems can be a bit tedious, kind of the nice thing about them is like, okay, it's the same steps every time. Find f prime, find critical numbers, number line, test. Your justification is always the same. It's just the only thing that changes is the function and the numbers that you get for the final answer here. The process remains the same. Part B, apply the first derivative test to identify all relative extrema. So let's see. So this was f prime, and this tells me about f goes from increasing to decreasing to increasing. I like to have this visual here. So I know that f of x has a relative max at x equals pi over 6 because f prime of x changes from positive to negative. Again, I'm okay with you writing plus to minus. Write out the actual words on the AP test. We should say what that is. What is f of pi over 6? Now, it'll be more specific, I believe, on the AP test. It'll either say find the x values at which there's relative extrema, or it will say, find the points of relative extrema usually, but I'm just finding it anyway. So it'd be pi over 6 over 2 plus cosine of pi over 6 because I'm plugging in pi over 6. I'm plugging into f of x. Pi over 6 over 2 is pi over 12. Cosine of pi over 6 is radical 3 over 2. And I'm just going to leave my answer like that. Okay, and then f of x has a relative min at x equals 5 pi over 6. And the reasoning for that is because f prime of x changes from negative to positive. What is f of 5 pi over 6? So it would be, again, 5 pi over 6 over 2 plus cosine of 5 pi over 6. And be careful here. So 5 pi over 12. Cosine is negative in quadrant 2. So this should be minus radical 3 over 2. Part C was to graph and verify. And yeah, looks like we have a relative max and then a relative min. Okay. The graph of f is shown in the figure. Sketch the graph of the derivative. Now, these are two pretty nice functions, right? F is a constant function. So f prime of x is equal to 0. So if I were to sketch that, really, there's f prime. I'll show that it's going through 0 there. So that's f prime. Oops, and that's supposed to be x. And here, we kind of need to estimate the slope. It's definitely not a slope of 1. It kind of looks like it's a slope of, this is a little bit iffy. I don't know. Rough estimate, I'm saying f prime is equal to 2. Slope of 2, maybe. Okay, so something linear anyway. So if this is 2, then I'm going to draw my horizontal line through it. And again, that's f prime compared to x. That's not too bad. Okay, we're doing 71 and 73 in this group. You could practice them all if you want. So assume that f is differentiable for all x. The signs of f prime are as follows. So f prime is positive for these x values, negative for these, positive for these. G of x is f of x plus 5. So how does g prime of 0 compare to 0? So we're supposed to write an inequality sign. Is it less than 0? Is it greater than 0? All right, so g prime of x would have to equal f prime of x, and then the plus 5 would become plus 0. So g prime of x equals f prime of x in this scenario. And we're looking at g prime of 0. That would equal f prime of 0. So when we plug 0 in for x, which is in this interval here, f prime is negative. So that's got to be that g prime of 0 is also negative. For 73, g of x equals negative f of x. So g prime of x will equal negative f prime of x. And we're supposed to find g prime of 6, or at least talk about its sign. So it equals negative f prime of 6. So what's the sign of f prime of 6? Oh, not 6. Sorry. I was like, wait, we don't know about 6. Negative 6. Negative 6. Negative 6 is in this interval on the top, and f prime is positive. So it's a negative times a positive. So g prime will be negative. So this one's also less than 0. Okay, and then 77 does not have to do with this group. It just says sketch the graph of the arbitrary function of f such that f prime is greater than 0. So your graph needs to be increasing. And then to the left of 4, and then undefined at 4, and less than 0 to the right of 4. So decreasing to the right of 4. Now, there are a lot of options. It doesn't say f has to be continuous. We just know these facts. So to make f prime undefined at 4, you either need to have a sharp turn at 4, or you could have a vertical asymptote at 4, like a discontinuity that makes f prime undefined. Or what else would make f prime undefined? A vertical tangent, like a cube root type graph going on at 4. Okay, so I think in my answer key, I did like a cusp of some sort. So here's 4. I need to make sure f is increasing and then decreasing. You could do like an absolute value graph would be totally fine. I think I made it fancy and put like a cusp up here. So there's an example. This isn't meant to look like it's still curving up though. So I guess I need to be careful with that. That's good enough. Yeah, so there are a lot of possibilities. It just has to be increasing and then decreasing and some sort of place where f is not differentiable at 4. 78 says a differentiable function f has one critical number at x equals 5. Identify the relative extrema of f at the critical number if f prime of 4 is negative 2.5 and f prime of 6 is 3. Now, what do they mean by identify the relative extrema? They don't mean find the number value. They just mean, is it a relative max or min? So that's kind of confusing. But when they say identify, it's relative max or relative min. That's the question. Or neither. Okay, so f prime is going from negative to positive. The numerical values do not really matter. To the left of 5, we're negative. To the right of 5. So it's like this. You have 5. You plugged in 4 to the left. You got that f prime was negative. And to the right, you got positive. That means f is decreasing then increasing. So f of x has a relative min at x equals 5. I'm not going to be able to find what it is. I don't have enough information for that. But it has a relative min at x equals 5 because f prime changes. How many times have we written this now? From negative to positive. Okay, every year this question gets people like, what is happening here? And it's because there's so many variables, I think. Or seemingly there are so many variables, I should say. So, okay, trachea contraction. Coughing forces the trachea, the windpipe, to contract, which affects the velocity of the air passing through the trachea. That makes sense. When you cough, you're forcing air at a higher velocity, right, through your trachea, through your windpipe. The velocity of the air during coughing is modeled by this, of course. Now, take a note here. R is the lowercase r is the variable. Capital R and 0 are constants. It says K is a constant. And capital R is a constant because it's the normal radius. Like you have a trachea, you have a windpipe in your body, right? And it has some sort of just resting radius. So that's a constant number. Okay, and then R is the variable because the radius, the lowercase r radius, is what's changing while you're coughing. Okay, so K is a number and R is a number. That's really important so that I'm not doing all kinds of crazy chain rule stuff. What radius will produce the maximum air velocity? So if I want to find a maximum velocity, that means that I want to know when is the derivative going from positive to negative. So I need to take the derivative with respect to the variable, which is r, lowercase r, of both sides of the equation. So I'm taking the derivative with respect to r of all of this stuff. And you know what? Maybe it would be easier to distribute, but I really don't think so. So I'm just going to kind of leave it like this because you'd still have an r times r. Okay, now this side is just dv dr. Let me get my pen to work again. So this side is just dv dr. And then I need to use product rule here. So here's a product and here's a product. And remember, K is a number and capital R is a number. So when we do first times derivative of the second, it's K times R minus R times the derivative of R squared, which is 2R. And the derivative is with respect to lowercase r, so there's no chain rule there, plus second times derivative of the first. So K is a constant, so it's still there. The derivative of capital R minus lowercase r. Capital R is a constant, so it becomes 0. And the derivative of minus r becomes minus 1. Okay, now let's clean this up a little bit. So let's see. I'm going to make this 2kr times capital R minus r. And this would just be k times negative 1. So this is just like negative k in here. So minus kr squared. Okay, remember, we're trying to find critical numbers. So r is our variable. I can factor an r out, a kr out. Let's get this equal to 0 and look at what we have when we factor. So factor out a kr and see what you're left with. So that would leave me with 2 times r minus r. Let's distribute that. 2 capital R minus 2r. And then that would leave me with just minus r. That made things a lot nicer. K times lowercase r times 2 capital R minus 3 lowercase r. All right, so remember, r lowercase r is your variable of interest. So it could be that kr equals 0, in which case r equals 0. It could be that 2 capital R minus 3r equals 0. If you solve that for lowercase r, you would subtract 2r divided by negative 3. So that's going to become positive 2r over 3. And we can toss these on a number line and see what v would be doing. Now, it's kind of hard to plug, like, how do I know what to plug in here between 0 and 2r over 3? You don't, because we don't know. I have no idea what a regular size of a radius of your trachea would be. I could make some guesses, I guess, but instead of plugging in numbers, remember, sometimes we graph these inequalities, and what kind of function is dv dr? It's kind of hard to tell, but let's go back to this line here. Let's go back to this line here where we simplified. V, if I distribute the kr through, v is equal to 2k capital R times r minus 3kr squared. So here's the important part. R squared and a term with r in it. That's a parabola that opens down. So that's a quadratic. So actually, I know that V's graph looks like this. V prime's graph looks like this. Excuse me, not V. So I know it's negative, positive, negative. Now, I'm not interested in a radius of a trachea less than 0. I hope that's not possible. I don't want to think about what that would be. But it means that the volume between 0 and 2r over 3 is increasing, or the velocity, excuse me, not volume, and then it's decreasing. So there is a relative max at 2r over 3. The question was, what radius will produce the maximum air velocity? So I'm going to say when lowercase r is equal to 2/3, when it's 2/3 the size of the normal trachea radius, there will be a max velocity. I think I wrote that more eloquently in my actual answer key, but that's the gist. Okay, true and false. I did not erase my explanations for these, so let me just talk through these. So the sum of two increasing functions is increasing. I'm trying to come up with a counterexample every time. I really can't think of how you could have an increasing function plus another increasing function and somehow get it to decrease. So that is true. And then I almost said true to 100, but then I thought of one. The product of two increasing functions is increasing. That's usually true, except think about this. X is an increasing function, 2x is an increasing function, but product means multiply them together. When I multiply them together, I get 2x squared, and that is a parabola which decreases and then increases. So not strictly increasing, so that one's false. Okay, 101 and 102 are related. So 101 says every nth degree polynomial has n minus 1 critical numbers. Not at least, not at most, not could have, has that many exactly. So I just thought of, okay, what if it's just x to the fourth? The only critical number I would get if I set f prime equal to 0 is 0. So I got one critical number even though it was degree 4. So no, because this is saying I should get 3 critical numbers if it's fourth degree polynomial. So that's false. 102 is true though. So an nth degree polynomial has at most n minus 1 critical numbers. So if it's fourth degree, like think of those W-shaped graphs, the most critical numbers, the highest number of places the derivative could equal 0 would have to be 3. And that's an algebraic rule that you have n minus 1, at most n minus 1 relative extrema for a polynomial. It doesn't have to be that many, but it could be. And then 103 is false. This was in our notes too when we learned about how to find critical numbers. So just because you have a critical number does not guarantee that there is a relative max or min at that value. So take the x cubed graph, for example. This is just one example. Even though I get a critical number at 0, I do not have a relative max or min. There's no relative extremum at that value. Okay, this was a long one because of all of the writing. We are guaranteed to have multiple questions about when something is increasing or decreasing. So that's why we're hammering this home, especially with the justifications. Come in and see me if you have any questions.